Today we're joined by Dr. Haimei Zheng and Dr. Catherine Murphy. Good to see you both. Thanks for spending some time with us. Also a big congratulations as well on having won the 2019 MRS Medal Award. Now your shared citation reads for outstanding contributions on the study of anisotropic nanoscale materials, transformation and application. I want you both to tell me a little bit about the work that led to this award. Catherine, we'll start with you.
Sure. Well, when we say anisotropic, we mean something that is not a sphere in terms of shape.
Okay.
So long ago, about 1999, 2000 or so, in my group we developed ways to make little bits of metal in colloidal solution where the final particle shape is rods. And you can change the size of the rod, some of the details of the rod performance. And what this means is we have different optical properties as a function of particle shape. So there's a long history in the field of metal materials where people have kind of seen this before, but we were able to develop methods to make these things reproducibly and high yield, and we do a lot of biological applications with them.
Now, Haimei, your work is very similar to that, but what do you focus on?
So my focus mostly on the imaging. Previously, all the studies is stop the reaction and see what had happened, trying to put together how the materials form. And we developed a method to directly observe the dynamic processes of the formation. So we can image using transmission electron microscopy to look at single particle formation, the nanorod form, for example, by nanoparticle attached together.
Now, what interested you first in getting into this field within materials science?
It's really, the nanoscience is a very fantastic world. I'm very fascinated by a lot of nanoscale materials, interesting properties and applications. And again, that most of the study is the post-processing, and I've been well trained in both materials processing and electron microscopy, and it's natural for me trying to put this together so we can study this directly by imaging.
Sure.
Plus, I'm in Lawrence Berkeley National Lab. We have fantastic electron microscopy facilities.
That doesn't hurt either. Now, Catherine, what drew you into the field?
So we were very interested in making objects that were the size of viruses, but were not actual viruses. So it turns out these little metal particles, you can grow them in the size of these biological entities, and then we can also functionalize their surface chemistry. So I like shapes, I like colors, and it turns out every different particle shape has a different color. So for me, it was a perfect, marriage of art and science.
That's great. Now, you each presented talks at the awards recipients forum. Catherine, you presented a talk, A Golden Time for Nanotechnology. Tell me a little bit about what you spoke on.
Sure. So since the metal particles we work with are mostly gold, that's where the golden time comes from. And also, it turns out there's just more and more work in the area, and so people are getting good at making all kinds of different sizes and shapes of gold particles. And again, that leads to all different kinds of optical-based applications, and also some more plasmatic type applications. So the field, the synthesis part is enormous, and now the applications are starting to bloom up. So I think it's a very good time, right?
I think so.
To be in the area.
Now, Haimei, you presented real-time imaging of nanoscale materials, transformations in liquids. So what did you speak in your presentation? What did you talk about?
And I briefly introduced the complexity and also beauty of these nanoscale materials transformations. And we have a very unique technique to directly image the dynamic processes. I gave a couple of examples. I especially highlighted one of amazing undergraduate student made contribution in this area. I hope it can inspire young graduate students to join in this exciting research.
I'm sure it will, absolutely. So once you get back to your labs, the meeting's over. Where does your work lead to from here?
Well, there's a lot of exciting things to do for us. In terms of imaging, there's very fast growth and technology, very exciting. For example, we can do much more in doing fast imaging, much faster, and vary the temperature and higher resolution, better control of electron beam effects, and there are many different systems we can work on.
You have a lot of work ahead of you.
It's a lot of work.
Catherine, same question for you. What's next?
Well, we are infinite in all directions. We do fundamental synthesis stuff, which now we're going to different metals besides gold and making bimetallic structures. We're also doing a lot more with the surface chemistry. So Haimei's been focused on watching particles grow, almost with atomic resolution in a liquid at real time. We're interested in the soft stuff. There's all these additives we have in the pot to help control the growth of these little crystals. And so we can't do it as fast as Haimei, but we can do some sort of stop, measure experiments to look at the organic-y stuff on the surface at different points during the growth, which will help us figure out the mechanism, which is very fun. And then we also have a lot of biological things we do, getting into sort of some sensing, some diagnostics, and even some delivery type mechanisms for like drug delivery type stuff, and also even some ecological work we do with collaborators to see where do these particles go in an ecosystem and what impact does that have.
Well, you have me excited. You need to get back to work as soon as possible. Catherine, Haimei, thanks for your time. Great to meet you.
Thanks, Chris.